Hey, how you doing? Sean Tech here. Welcome back to the show again. So, I I am a nerd. Hmm. There's a little bit of a thing there. Normally, I'm even so nerdy, I am not wearing the thing that ties my glasses around the back of my head right now, but normally I do. And being a nerd, I am a fan of nerdy sci-fi things like Star Wars and Star Trek and all that other cool stuff. Especially Star Wars, though. I have some of my fondest, earliest memories of watching Star Wars when I was a very little Sean Tech was when my dad, Papa Sean Tech, had the Star Wars Episode 4 on VHS, and we had this old JVC VCR that you could play things, and that you could run over that thing with a Mack truck, and I think that thing would survive. But honest to goodness, I do love Star Wars. Big fan of it. I'm a fan of lots and lots of the old like sci-fi stuffs as well. Star Wars, Star Trek, Mystery Science Theater, that kind of cool stuff. But anyway, one of the things that I got my kids into was Star Wars. My children love Star Wars. Such lovable characters, good guys and bad guys. Lots and lots of pew pew pew, lightsabers and laser battles in space. I love the battle in space. That's what sold me on Episode 4 as a kid. Was like they're they're battling with lasers in space. Oh, that's so cool. But anyway, I got my kids into Star Wars, and we have like all sorts of action figures and toys and movies and shirts and dresses and pajamas. And my 6-year-old is a big fan of Luke Skywalker in particular because he's the good guy, and she really likes the color blue. And so one of the things that we've got the kiddos was was lightsaber toothbrushes. Isn't that cool? It's a lightsaber toothbrush. So like inside you take the little plastic part off, do it there. You see that? And that's and if you press the button, it lights up and it makes noises and pew pew pew, and you get to brush your teeth, and it has a little timer somewhere on the inside that keeps track of while it's doing. See, and it helps kids like with sound and lights to keep them brushing their teeth as long as the toothbrush is still going. It continues to light the teeth. So my 6-year-old really likes the Luke Skywalker brand of or whoever there's all sorts of different good guys within it there. But then the my 4-year-old really loves Darth Vader. Which is just, it's so funny to me that that's kind of what that is. I can't help that. But unfortunately, her toothbrush has has a little problem. I think the batteries have died out, and it doesn't. I think this is the Kylo Ren version of this. I'm not entirely quite certain about that, but she really likes the color red for Darth Vader. Darth Vader is red after all. So we got her this, but the batteries have died out, and she's really really sad right now because her toothbrush is not working, where my 6-year-old toothbrush is working. And so I thought, well, what better way than to see what are the electronics on the inside on the inside of this thing. So without further ado, let's open her up, shall we? So now looking at this thing underneath the microscope here, we can tell that. Can you all see that? Okay. Can you all see that? There are in fact two Phillips head screws. Sorry, one on the top and one on the bottom of the lightsaber. Toothbrush teeth. I have two toothbrush teeth. It's not teeth brushes. I think it's toothbrushes. Right? John, my lab tech, told me that the toothbrush is a Western Virginia-based invention, and so it's something that we need to kind of examine with there. So I've got a little screwdriver kit right here. Let's open her up. So take the screwdriver out. I've got the actual part to hang on to. I've got a little magnetic bit holder, and then on top of that I will need some sort of a screwdriver bit. We'll use the Phillips screwdriver bit. Let's open her up and have a kind of a look inside. See kind of what we got here. So I'm gonna start to open her up here and start to loosen up the screw. Hopefully these are some sort of, that fits rather nice. It's a little bit loose, but that's okay. That's okay. And I think I've got this bit is magnetic, so I'm able to lift the screws out. I can't tell you how handy that is when working with small parts, to be able to have something that automatically grabs them. I'm actually kind of trained to be able to open up some of these parts and hold on to, like, with a pair of, like, you know, almost with a pair of, like, screwdrivers. I've got this thing like clamped into place, like come in with a pair of tweezers to sort of lift the screw out of there if I had to. But with magnetic bits, I actually kind of don't need to be able to do that, which is so nice. You know, it is. So anyway, let's so I think looks like this thing should just pull, and it does. Just kind of pulls itself off there. I got a little piece in my hand of it here. I'll put that off to the side, and a little tray. I got a little tray for the screws, so I'll put that along with the tray. One of the things I noticed right away, looks like I've got some sort of a speaker. Yep, definitely a speaker. Yeah, wires. It's on there. I see a speaker. I'll try to keep a light source going so you can all see kind of what I'm doing. It looks like this should somehow kind of slide out. Is that what that is? Let me grab a wedge, kind of more of a plastic wedge. Do I have a wedge in here? That should work. I've got a little kind of a plastic wedge, so I'll kind of wedge this thing out so that I don't damage any of the plastics. Okay, so I'm kind of starting to pull something out. The speaker, there's wires going somewhere deeper on the inside of this. I can't tell. Oh, that popped out right there. Oh, look at that! There's a little circuit board on the inside of the toothbrush. That's so cool. Look at that. I mean, that is actually really, really kind of neat. Wow, that's really cool. Look at that. What is? Okay, so that's something that's interesting. Okay, so do you see this part of the toothbrush here that says U1? You see that part? There is a sort of a a blob that is kind of stuck to the top of the circuit board, is what that is. So what that blob is, for the most part, that is what we would call a glob top. And what that is specifically, that it's a form of packaging that's sort of a low-cost packaging method, unlike circuit boards that we've kind of been working with in the class, which are more like for instance, I've got this guy right over in my hand here. This is a simple little circuit board. It's about the same size overall. Unlike the circuit board that you see here, this circuit board has at the end of it a chip, more of a microchip, and that's where the term U comes from. You see U on a circuit board, that usually refers to a microchip or a microprocessor, or something that's got some higher levels of memory-based functionality. In particular, that comes from the Greek symbol mu, being the symbol for the prefix for micro when it comes to engineering prefixes in mathematical terms. So the Greek letter symbol mu means micro. Now, if you were to look at lowercase Greek letter mu, it looks like a Q that has the top part of it just sort of scissored and sliced off. So it looks like a U and then like a straight line down is what it looks like. Now, most keyboards don't have that, at least not in the Americas, they don't have that. So instead, we cheap out and just say the letter U, because it kind of does look like a U if you were to leave the longer stem off on the left-hand side. And so a lot of folks that are in the engineering and science areas, they make the Greek symbol mu is actually, the symbol is U, and since it means micro, they call it microchip, and that's why you'll see on circuit boards, if you ever see the symbols on there for U, that usually means there's some sort of a higher level microprocessor somewhere on the inside of there, which actually means I'm just going to, just for safety, I'm going to wear my ESD wrist strap for this, just in case. I don't want to shock Darth Vader's toothbrush off into non-existence. That would make my daughter very sad, is what I would do. All right, so but that's really cool. So there is actually a microchip on here that's glob top. That's kind of like, so rather than put a whole chip on there, they put like basically a bare chip that's on this thing. Somewhere underneath it that's connected and then just kind of smeared over on the top with some epoxy that is not electrically conductive. Is what it is. That's made by companies like Loctite and Hysol and that kind of stuff. So, but anyway, but yeah, so underneath there, that's the micro. I'm guessing that's the part that all the sound and everything is coming from. That's probably, I'm gonna guess that's the only microchip. I see some solder joint connections up there. Look at those. Look at those solder joints there. You see those? Ugh, those are terrible. Who did those? That looks like the wires that are going to the speaker. That is not it's so shiny. Is that lead? I think that's lead-based solder. Sure looks like it to me. Sure looks like lead-based solder to me. I mean, the difference between lead and lead-free is that lead-based solders, like solders that contain tin and lead, which is your typical easiest to process and often in many cases cheapest to process solder, is more shiny and lustrous when you're looking at it in the light, whereas a lead-free based solder joint, which usually contains like tin, a large amount of tin, and a little bit of some copper and silver inside of it, like 3%, like in the copper silver kind of areas, that kind of stuff. Varies from one material to the next, but it looks like it has a dull matte finish once it's done. So that's unusual for me to be able to see something like this. That really is kind of an unusual thing. But yeah, that looks like lead. That's lead that my daughter brushes her teeth with inside the. That's evil. Darth Vader, that's evil. So, all right, moving onward, we'll kind of come back to that at some point. Gosh, I don't know if they want them using these toothbrushes anymore. I see that there is it looks like maybe a fuse or a resistor there, some sort of a protective-based resistor. Yeah, a whole bunch of capacitors that kind of line up the bottom here. You know, if I were looking at the solder quality of some of these joints, I would say they're okay. C3, that left-hand side looks not so good. It looks like the wetting on the one side of the capacitor does not look all too good. There, C3, C1, C1. Now, why couldn't you put them in order? Well, we'll get into that a little bit later on. We'll actually design a circuit at some point on here and actually go completely from design to first functioning prototype. I see an additional resistor here. I see these things that are sticking out of that looks like it's part of the plastic casing, which on the back end part looks like that's where the batteries are. That's so cool. That really is kind of neat that is kind of all on the back part of it. It really is kind of a neat thing. So those are the batteries, and that'll actually. Can I just kind of wedge you out? Can I wedge these? I'm gonna use the plastic tool. Can you come out of Darth Vader's, Kylo Ren's, the red lightsaber? Ugh. Can you please? Hey, come on. Oh, jeez, that popped out. My guess is that the batteries are dead. So we'll verify that here in just a second there. But look at that. Look at the little push button that's on. Hey, I know that push button. That's the same one that I get. All right. Hey, look. Hey, how's it going? Oh, that's fine. We come from the same family, brother. Hey, little sister, brother. Yeah. I'm doing puppet shows with circuit boards. This is a new high in my entertainment in terms of what I do. But anyway, yeah, that kind of looks like they're the same ones. See, I actually could probably name that exact same switch that they've got on there. That's kind of cool. Kind of cool to be able to see. And there's the LED that's at the end of it that lights up with a red. And then you see down at R1 there is a 100. So that's a 10 ohm. That right there is a 10 ohm resistor. 1, 0, and then zeros following at the end. 0, zeros following after the end of that. So that is a 10 ohm resistor of something. I'm not sure what that actually goes for there. That's really cool. That's really cool. And all of the solder joints look like they are lead. Look at the solder joints that hold the battery clip into place. I mean, that's so shiny looking. That's got to be lead. Huh. We'll have to do an investigation a little bit more with that one there. But anyway, let's verify. I've got 3 batteries here. The batteries appear to be, let's see, LR44H-based batteries, and with 0% mercury. 0 Hg is the chemical symbol, the stoichiometric chemical symbol for mercury, is what that is. Let me grab my multimeter. Set it to measure DC voltage, which is DC voltage is the V that's the V that's got the couple of bars that are going through it. That not the one with the squiggle, right? That's AC. Right? If I can't, I will not get a very good measurement if I measure these with AC. I need to measure these with DC. So let's have a look. See here. See if there's one of these batteries might possibly be dead. That's what that is. So I'll try to put this on the screen, so hopefully you can see that there. Hopefully I can see that there too. I need to be able to see that in order to make an actual measurement with it. So let's see here. I'm going to take multimeter probe tips. Oh, excuse me. Can I measure you? Can I measure you? Is that okay? Oh, excuse me. Probably measuring with the polarity a little bit messed up there. 1.3 volts. 1.3 volts. Yeah, these are probably somewhere around 1.5 volts. So that one's kind of low. I think probably around 1.5 or 1.6 volts, somewhere in that range there. I think that's where these batteries actually kind of fall. That one says that says 0.985. That battery is most likely dead. So that battery is very most likely dead. I mean, they're all probably kind of low. My kids, we do a lot of teeth brushing in here. We do a lot of teeth brushing. And then 1.3. So yeah, it looks like one of the batteries is very, very low. Why one is low compared to the other ones, I'm not sure. Just nature of kind of maybe what happens. Maybe some moisture got into it or something like that. I'm not sure. But we found the culprit inside the toothbrush scenario. So very interesting to see. What do you all think? What do you all think of those solder joints that are on the inside? I mean, in all legitimate honesty, those do not look like lead-free solder joints. Those look like lead-based solder joints. But what do you all think? Leave a comment in the comment below. Let me know what you think about this. Let me know what your opinion is. Should I assemble this back together again and let my kids brush their teeth with this? I don't know. So, all right. Well, anyway, thanks very much for coming on in and watching this here. I'll try to make another one once we get the new batteries. I don't have these batteries lying around. I'll probably have to order them in. Once we get them in, though, I'll make a new video so that we can upload that up and see a little bit more about whether or not this actually works correctly, whether or not we can get Darth Vader going again in the teeth brushing area. All right, thanks very much for coming. We'll see you on the next video. Bye-bye.